Okay, so today we're going to learn, we're going to refresh our memories. We've already talked about the four steps of solving linear equations, and one of the steps is, at least one of my steps, right, that I've already discussed is how we want to clear fractions and decimals. Well, this lesson is basically focusing on just that because it's one of those skills that a lot of students need to practice. It's not something we do in our everyday lives. It's not something we've done a lot probably in our school history. So it's a good idea to spend some time talking about clearing fractions. So my suggestion always is, if you are really good at finding least common denominators, you can do it quickly, easily, efficiently, and you won't make mistakes, then by all means, please do it that way. The truth of the matter is, my experience has been that very few people can do that. So instead, I've developed kind of an easier technique. It might take a little bit more time, and it might take a couple steps extra, but it's so much easier and so less likely to make mistakes. And that technique is to simply pick the largest denominator, right, the largest number on the bottom, and go ahead and multiply through every term by that denominator. And hopefully you'll kill off multiple fractions. And then if any fractions are left, repeat the process and keep doing that until all of your fractions are gone. Just remember that when you do this, you have to hit every single term. And remember, terms are things that are separated by pluses and minuses. Obviously the equal sign as well. So we have three terms sitting here, and the largest is 6. So we're going to multiply all three of these by 6. Well, when you multiply 5, 6 by 6, right, they reduce, and you're just left with 5x. And then negative, right, this is a negative, so negative 6 times 3 is 18 over 4. And then when we do 6 times a third, the 6 and the 3 cancel, right, and you basically get 2. You can reduce this to 9 halves. And then if you're, comfortable working with 9 halves, you can do that. But again, you can just repeat the process by multiplying everything through by a 2 this time. So you get 10x minus 9, because those 2 just cancels, equals 4. And now we've basically reset the equation. And that's the whole point of all these steps, is we take an equation that looks relatively difficult in our mind's eye. We do a couple simple mathematical operations to it, and it gets simpler and simpler and easier until it gets to something like this. We've kind of reset the bar now and go, okay, I can do this really easily. All I have to do is add 9 to both sides, and then divide by 10, and I get x equals 13 over 10. So that's what it means to clear fractions. So here's the steps that we've talked about before. Step 1, simplifying both sides usually means clearing things. You want to clear parentheses, or what I call grouping objects, because later on we'll learn there are 2 other grouping objects to worry about. Then you want to consider clearing fractions and decimals if they are there. Again, if you're comfortable working with those things, you don't have to do that. Then you combine like terms on each side of the equation, right? That's why this says both sides of the equation. Then all this fancy stuff means you isolate your variable. You put all your variables on one side, you put all of your other things on the other side. For the basics, you'll be putting all of one variable, like let's say we're solving for x. You'll put all your x pieces on one side, you put all your constants on the other side, and then you'll combine those. You'll basically do the simplifying again, where you combine like terms, right? You basically do this step again. And then once that's done, you use multiplication or division to get rid of the coefficient in front of your variable, which I say just means to simplify the variable. So instead of having 5x equals something, you divide by 5 and have x equals something. Instead of having 1/2 x equals something, you multiply by 2, so you have just x equals something. And then you're done. Last thing you do is you check. Okay, so when we have something like this, you don't have to do these steps in the order in which I've presented them to you. The order I gave them to you is kind of the most efficient order, and it's the one that will make your path to success easiest. But again, if you're good at certain things, you can do certain things first. Like if you wanted to move the 2/3 over here and combine it with 1 first, you could. If you wanted to move this over here and do a common denominator, combine your x's, you could. But I think all of that's just a big fat pain in the butt, and it's going to be a lot easier to pick my largest denominator and multiply everything through by 6. Don't forget the 1, right? That's a term. So this just gives me x. 6 divided by 3 is 2, so 2 times 2 gives me -4. This doesn't do anything, right? It's just 6/5 x and then minus 6. Now at this point, if you want to combine your numbers, that's totally fine, right? I would add 6 and have x plus 2 equals 6/5 x. You might want to add 4. I just like to have positive numbers. It just makes my life easier. So now if I put the bigger number over here, it's going to make it a positive number, and I don't have to worry about dealing with negatives. Now I can repeat the process because I still have a fraction, and I'm going to multiply everything through by 5. 5, 5, 5, right? This is going to cancel. You're just going to have 6x here. This is going to be 5x. Of course, 5 times 2 is 10. Now, subtract my 5x from both sides and get 10 equals x, and I'm done. So here's another example. Now, one of the clearing things is clearing parentheses. And you could always do that first, and you could distribute this fraction, each of those fractions through. But isn't that going to suck? Because you're basically just going to throw fractions onto everything. And why would we want to add more fractions, right? So if you understand that when this is written like this is all one term. And this is all one term. Because it's all stuck together by multiplication, right? It's 1/2 of this junk. You can think of it as it's like 1/2 of a box. And this is 1/3, right, of a triangle. It's almost like if you wanted to use a different variable, right? It's 1/3 w minus 1/2 z. It just so happens that w actually equals x plus 7 and z actually equals x plus 1, right? It's that kind of idea. And if you can visualize that, and if that's okay in your brain, then it's going to make it a lot easier for you to get rid of these fractions because you don't have to distribute first and get more fractions and then deal with multiple fractions. Instead, treat it as a term, pick your largest one, and multiply through everything by 3. It's going to kill off this fraction, and you're just going to have x plus 7, and then minus 3/2 x plus 1 equals 12. We can go ahead and combine like terms just to kind of clean things up for now. Because again, we don't have to do these all in one pre-prescribed steps. Whatever kind of helps clean things up. It's always good to just constantly clean things up. We're left with a fraction. So we repeat the process, hit everything with a 2. That gives us 2x. Of course, these cancel, so we're minus 3 times that equals 10. Now the fractions are gone. Now we can get rid of our grouping objects by distributing the -3. So you have to hit each thing with a -3. You get -3x, and then a -3 times 1 equals 10. Again, combine like terms on each side. So we've got a 2x minus 3x, so we have minus x minus 3 equals 10. Then we can move the 3 over and have minus x equals 13, right? So of course x equals -13. How about another example where we've got these big ugly looking fractions? Well, it doesn't matter how ugly the fractions are, as long as we've got fractions, it's the same darn technique. I'm going to start with the largest one, multiply everything through by 5. The 5 is going to cancel this, and we're going to be left with x minus 2. Then this one, I'm just going to get -5. Oops, times x minus 4 all over 2. That doesn't help me yet. And that's a 10. Again, I can add the 2 over here to clean it up. X, sorry, this is, I don't know why I put an equal sign in there like a moron. It's just x minus this whole thing. So we've got x minus, you can think of it as 5 halves, right, times x minus 4. That might make it easier to sit in our brain, just like this would have been 1/2 times the whole thing. Remember that when we have fractions, the whole thing on top is in parentheses, and technically the bottom is in parentheses too, but if it's just one number, we wouldn't put parentheses around it. So now we're going to repeat the process. Multiply everything by 2. 2x minus 5 times this stuff equals 24. Distribute. Again, remember you're distributing the whole thing. You're distributing the minus to both pieces. So you get 2x minus 5x, but then minus 5 times minus 4 gives you plus 20. Combine like terms, so negative 3x plus 20 equals 24. Subtract your 20. And negative 3x equals 4. Divide by negative 3. X equals negative 4/3. The next concept is same kind of stuff, but now we're going to clear decimals. And there's really no difference to clearing decimals and fractions. The only minor difference is instead of multiplying by the largest denominator, you're just going to multiply by tens. If you have one decimal, you have to multiply everything by 10. If you have two decimals, you got to multiply everything by 100. If you have three decimals, you're going to multiply everything by 1,000, right? That's the nice thing about decimals, is they're nice and easy to get rid of. Again, if you're comfortable working with decimals, you could go ahead and just subtract the 3 over here and do that in your calculator. Subtract the 1.7x over here, combine those in your calculator, and then divide by whatever coefficient is in front of your x when you've done that math. That's totally fine if you're comfortable with that. If you're not, then since we have one decimal, right, that's the largest amount of decimals we have, we're going to hit everything with 10. 10, 10, 10, and 10. And when you do 10, right, everything just moves, and you get 25x plus 30 equals 17x minus 66. And now your brain goes, oh, that's so much easier for me to understand what's going on. I can subtract 17x from both sides. I'm going to bring it over here to keep things positive, right? 25 minus 17 leaves me with 8. Then I'm going to subtract the 30 to get 8x equals negative 96. Terrible 8x. Then divide by 8 and get x equals 12. Another example, just like the previous one, where we had, or was it this one, where we had to realize, okay, if we have a fraction times some crap, that's just one term. Same thing here, right? If we have a decimal times a bunch of crap, it's just one term. Now, you could distribute the decimal. You could distribute that coefficient if you want to. Or you could remember that this is one term, this is one term, this is one term. So if I multiply everything through by 100, right, because I got to do 100 because I now have 2 decimal places, that you only multiply each term. You don't multiply all 3 of these things. You just multiply the blob once and the blob once. And since you've got a number on the outside, you go ahead and multiply the number on the outside by that constant, in this case 100. So if I hit this by 100, it becomes 20 times x plus 4 minus 45 times x plus 9, and then equals 1200. Now you can distribute 20x plus 80. Don't forget, the negative goes with it, so minus 45x, and then minus 45 times 9, which is 45 times 9, 405 minus 405 equals 1200. Combine like terms, right? So 20 minus 45 gives me negative 25x, and then 80 minus 405 gives me negative 325. Now, the most efficient way is to add the 325 over here, but that leaves your constant negative. It's fine now because it's an equality, but remember when we have inequalities, we always want to keep our variable positive because the last step is going to be dividing by its coefficient. And when you divide an inequality, right? Something with a little alligator mouth. When you divide an inequality by a negative, you have to remember to change the direction of the sign. So if we can avoid that by always keeping these things positive, we don't have to remember that one little tripping point. But since this is an equation, it doesn't matter. We can just add 325 to both sides. Negative 25 equals 1525. And then take 1525 and divide that by 25. Oh, sorry, there's still an x there. And x equals negative 61. Okay, well, that's all I have for this lesson on getting rid of fractions and decimals.